Hello, everyone, and welcome to the first edition of the Chaos Week. We will wait for about 2 to 3 minutes to let all the attendees join and make themselves comfortable. I hope also that you have seen the previous talk for the first and the second day of the Chaos Week. They were very interesting. They were about chaos engineering, of course, on Kubernetes, AWS, and also we have chaos engineering by numbers, which explains the discipline, how to use it, how to implement it in enterprise, and the mindset behind it. I hope that you will return to the WeScaleTV and see all the previous videos that were recorded. As we have said, we will wait for about 2 to 3 minutes to begin. And once we get the 2 minutes, 1 minute, we will begin our talk. So let's go. So welcome again. I'm Akram Ariai, Litmus Chaos Leader and a cloud builder at WeScale. I would like to thank you all for attending this talk of the third day of the Chaos Week. As you may know all, that the chaos engineering is one of the main topics nowadays, and it also particularly interesting for us at WeScale. For that reason, we wanted to share with you via a free and an online event that lasts for 4 days. The program is already published in the website. Well, our goal is to make accessible to you a vision and some expert insights and feedback on this topic. I would like also to add that the chaos engineering has been integrated as a discipline in many companies' strategies to help for their continuous improvement of the infrastructure, as we have seen in the previous talks of the Chaos Week. For that reason, that I'm very happy to welcome today Ramiro Berrelleza, the founder and the CEO of the Okteto Cloud, and he's also an active member in the Litmus Chaos community. Ramiro will be talking today about the continuous chaos testing with Kubernetes and Okteto.
Hi, Akram. How are you?
I'm fine, and you?
Good morning here. Good. Thanks. Thank you. And hi, everyone. Very happy to be here in Chaos Week. Thank you. Thank you for having me, and thank you for putting it at a time that works for both California, where I'm at, and Europe. I think you're in France, right, Akram?
Yes, it's France. Yes, it's Paris. Yes, it's a pleasure to welcome you for this first edition of the Chaos Week, Ramiro. And I would like also to thank you for joining us today. I will I will let you now take the lead, and I wish everyone a pleasant conf. And I will come back later for the Q&A session that will be posted on the posted so everyone can see it, can see this question that Ramiro will answer it.
Well, perfect. Thank you, Akram. And once again, hi everyone. Let me start by sharing my screen, and we'll get started. Today, I'm going to talk about what I've been calling continuous chaos testing, and I'm going to show you how to do it with Kubernetes, Litmus, and Okteto. So nice meeting you, everyone. I'm Ramiro. If you want to chat after the talk, you can find me on Twitter and most other dev communities as Ramiro Berrelleza. Before I start, I'll give you a little bit of background on me. I've been working in DevTools now for a very long time. In a previous life, I used to be an engineer at Microsoft. Most recently, I was an architect on the enterprise group in Atlassian, the makers of Jira, HipChat, and other products. And today, I'm one of the maintainers and founders of Okteto. Okteto is a company where we build dev tools to make it easier for teams to build cloud-native applications. As part of that work, I got involved with the Litmus community, with the first chaos engineering, then with the Litmus community. And that's what I'm here to talk about how we've been pushing the use of chaos engineering techniques as part of the development cycle, and how easy it is to get started with Litmus, Kubernetes, and Okteto. So just to set the context, I know that everyone here is pretty much an expert on the topic, but I always like to start with this quote of, what is chaos engineering? For me, it is the discipline of experimenting on a system, and we do it to build confidence that our system will withstand any odd condition in production. The quote is from Principles of Chaos, one of the seminal sites on this topic. But I really like those two aspects of this. It is a discipline of experimentation, and we do it to build confidence. And that's something important to keep in mind, right? Building confidence in our systems. Why does this matter, though? Why do we need to build this confidence through experimentation? Why not just, test our things? Long time ago, that used to be the thing, right? If you think of how we're building software, maybe 10, maybe 15 years ago, this was pretty much the cycle. You write some code, you build it, you test it, and then you're good to go. And every time there's a change, you repeat this cycle. And that was it. It was very simple. It was very straightforward. Typically, you had a binary or like an RPM file at the end that you will SSH into a production server, copy there, deploy, and that was it. It was very easy to replicate locally, and we kind of had some control. There were other challenges, but it was easy to understand what was going on. But then, there was a big change in how we build software, especially with the advent of VMs, containers, and then microservices. Microservices are great. They allow us to build applications that scale a lot more than before with bigger teams, but they did have some challenges. And the main challenge is that we went from that cycle of code, build, test to a far more complex software development lifecycle where, you have a local version of the code. If you're using something like Git, you're going to write your code locally. You're going to test it. At some point, you're going to send a pull request, which then is going to trigger this process of testing, CI/CD, and then all the way to deployment. And we had to move to this model because we got to a point where if you have too many microservices, or if you're building a very complex application, you're no longer able to validate things locally, right? You have so many services that you might not be able to run them all locally, whether it's because of technical limitations, or because it's very expensive, or because it takes many resources, right? Imagine that you have a web API that's calling a very large Oracle installation. That's not something you can easily replicate locally. So that's where this kind of push for testing, CI, validation came to be. And along with that, we started to understand better how software is made, where we need to focus on, and the cost of errors, right, of bugs. And this is from a Gartner report, where it's a very well-known fact that the later in the cycle that we find an issue, the more expensive it is. If you find your issue when you're thinking about how your code will look like, it's very cheap to fix. You just think of a new design. If you wait all the way to production, the estimate is that it's about 30 times more expensive. I was talking to one of our early adopters the other day, and they run this internal metrics, and they did this analysis. And for this company, which is it's an e-commerce company, very large, they found that every production issue added 1 week of work to their engineers. Everything from finding the issue, rolling back the code, trying to figure out. So imagine you have your work, which as we all know, right, our schedules are normally already packed. And suddenly you have another week of work, which normally means you have to postpone something else, and then the productivity team will go down. And that's why it's so important to find things earlier. And that's where chaos testing came to be. Chaos testing is one of those things that we know is important, but that typically we do until the end. So I'm here to tell you, I'm here to kind of plead to you to start chaos testing as soon as possible. Do not do it until everything is in master. Do not do it until everything is ready to go to production. Do it as soon as possible. How soon you should do it? When you're writing the code. Going back to this, remember, the farther left we are on this graph, the cheaper it is to find issues. So if we wait until after acceptance testing to then do this kind of testing, it's going to be 15 times more expensive if we go by this graph. That's one of the biggest reasons why there's this huge movement now of shifting left a lot of testing. And right now, shifting left is very focused on security analysis, end-to-end testing. But I'm here to kind of tell you that you should also think about shifting left all your chaos testing techniques. And today, I'm going to show you a few examples of how to do it, because it's something that when I talk to people, they find it hard to grasp and confusing to, like many others, where as you build your expertise, you'll get right to it. So by the way, I'm going to pause here. If you have any questions, put them in the chat. And then at the end of the talk, Akram and I will go through them and we'll answer as many as we can. And if you don't get a chance, you can always find me on Twitter after the talk if you want to continue the conversation. So the key part here for this shifting left chaos testing is that we need to enable our developers to do it as often as they want. You want to put the tools in the developers' toolkit so that anytime they feel like, hey, I have a big piece of code, let's test this. It's as easy as clicking a button. It's as easy as running a script. You don't want them to have to go through like 3 hours of setup and things just to figure out how to run a test, because if you do that, they are never going to run those tests. So a big part of this shifting left movement is to make sure that we as developers have the tips, the tools are in our keyboard, in a shortcut, in a script, and not having to go through this very complex setup. So today, I'm going to talk to you about two tools that can help you to bring chaos to your development environment. The first one is Litmus. Very well known, I would say one of the most famous chaos tools right now in the cloud native world, and Okteto, which is some of the open source tools that we made at my company. So first, Litmus Chaos, for those of you who don't know, it's a CNCF sandbox project. It was initially created to help SREs and developers practice chaos engineering in Kubernetes. Now, through community contributions, is growing way more than Kubernetes, but still very focused on the practice needed for that platform. It's, as I said, open source. It's part of CNCF. I'm a maintainer there. And if you go to github.com/litmuschaos/litmus, you can check it out. It's very easy to start. They have great documentation and a very involved community, very friendly, and always willing to help each other. Actually, in KubeCon, which is going on right now, they have a lot of talks, and they even have some office hours if you want to talk to the team building this. The other tool I'm going to show you today is Okteto CLI. It's also an open source tool. We licensed that as an Apache 2.0. It's on GitHub, github.com/Okteto. And Okteto is a CLI that allows you to deploy pre-configured development environments on any Kubernetes cluster. I'll show you in the demo how you can combine Okteto and Litmus to have this very fast dev cycle where it's going to be as easy as write code, change 2 or 3 lines of your application, and then run your chaos experiments by using these two tools. So I hope you find it useful. I'm going to switch from boring slides to actual code and demo. And as I go through the demo, I'll show you different pieces. And just to clarify, for this demo, I'm going to use Okteto Cloud, which is our Kubernetes dev platform, but everything I'm showing you today works on any Kubernetes cluster. I'm going to put the code on GitHub. So if you want to try this out on Minikube, on K3s, on a full cluster on JKE, you're going to be able to. Just today, to keep things simple, I'm going to use Okteto's namespace as a service feature, but it works everywhere. So time to go to the code. So what I'm going to do today. So today I'm going to show you how to build an application. To start, I created this kind of simple application. Is defined, as you can see. There's two things you want. It's defined as a Docker Compose. The Okteto CLI, we just released this new feature where you can deploy Docker Compose files on Kubernetes through the CLI to make it simple to test things in a remote cluster. One extra thing that we added, that you see here, is that we expanded the notation of Compose to do things like specify the endpoints of your application. So in this case, it's a fairly simple app. It's a GraphQL server that has a gateway, has a service that returns a list of books and lets you add more books for those of you who like to keep track of what's on your bookshelves. And everything is backed up on Redis. And it has an endpoint to the gateway to access the API. So the first thing I did is I deployed this application. Application's been a node. All the code is here. We'll go through that in a second. So I'm going to show you this dashboard. Like I said, this is using Okteto Cloud, but it's something you can use on any cluster. I like using Okteto Cloud because the UI is pretty simple, especially for demos. You can see the components in a pretty easy way. So you can see now we have a books service, we have a gateway, and we have Redis. So let's first, I always like to kind of get my application and try it out before we get into the chaos testing part of our day. In this case, I have Insomnia. Insomnia is a GraphQL client. It's very similar to Postman. Postman, more focused on GraphQL, which is something that I use a lot. If you're building GraphQL APIs, I highly recommend it. So in this case, we have the service that you do a query to get a list of books, and you get the ID, the title, and the author. So in this case, I'm going to call the API. It's empty, of course, because we haven't used the application yet. So I pre-created some queries here to create some books. So in this case, you see 100 Years of Solitude, another entry here. I'm going to call it Telegraph Avenue. Another one, White Tiger. These are just books that I recently read that I really like. Working in Public, great book by Nadia Eqbal on building open source communities. Highly recommend. You see there's a typo here. Let's fix it. Working in Public. And you'll see that just to prove that the API actually works. And finally, Founding Sales. For those who are starting your own company, Founding Sales by Peter Kasanji, great book on sales. That's something that now that I'm the CEO of a startup, I've had to learn a lot of. So this is a great book to kind of help you get started. So going back to the books query, we're here. And you see that now we have an API that's populated. We call it a few times. If we go back to application, what's happening here is that we have an entry point that's going to the gateway. Actually, let me show you the code instead. We're using this GraphQL gateway. The request gets here. The gateway now knows how to route to other services based on the payload of the GraphQL request. In this case, we only have one service, books, so it's going to forward things to this one. You'll notice that I'm using the service name because I'm on Kubernetes. And then books will handle the request, it defines some schema, and then it's going to do this thing. When you call the books query, it's going to go on Redis, get a list of books, get us the details. When you do the add book mutation that I just called, it just puts the books on Redis. That's it. It's a very simple service, but I like this to kind of show you like what a typical microservice application looks like, where you have a store, and then you might have a couple of services, an endpoint, a proxy. In this case, you'll notice I'm accessing everything through HTTPS. That's something that I like when I'm developing, so that I have a more realistic environment. I'm calling this service the way that I'm expecting my customers to do it. So we have the service working, right? So now let's do some chaos testing before we even get started. For today, I'm going to use Litmus, as I mentioned. This is the latest release, beta 2. Well, not the latest. They released something a couple of days ago. So this is beta 2.4. Beta 2.5 is out. I highly recommend you check it out. You get a Helm chart and deploy it on a Cube cluster. Or if you go to Okteto.com, you can also deploy it there for free. So I'm going to log in. This is one of my favorite things about Litmus. Litmus has this very kind of like UI-driven approach that I like a lot when I'm working as a team, when I'm working with other developers. I log into my portal, and I can see like everything here by just clicking on things. This is, for instance, an example of the experiment that I'm going to show you today that I was testing yesterday. So I can go here and imagine this was done by somebody else. It doesn't matter. I have my history here. I can see the graph of the experiment. You can click on any of the steps. You can see the logs, in this case, that it worked. When was it done? And this is a very simple workflow, and I'll walk you through it in a bit. But what I want you to get from this is that if you start using Litmus, think of this not just about what does it do for you as a developer. Think of what can this do for you as a dev team or as a company. One of the biggest things about their portal is that then when somebody sets this up, everybody else just benefits from it. They have things like a Chaos Hub where you can create a repository on GitHub and put your own experiments. I created some here that I have for very specific things that I need for my own application, for the data stores that we use. The Chaos team, the Litmus team kindly has a public repository with like more generic experiments, which is the ones I'm going to be using today. But as you write your own, you can either send them back to them. But if it's something very specific to your application, and I do recommend that as you get started with your Chaos engineering practice, do start building as specific experiments as you can do. You can put them on a hub and make them available to everyone in your team. So that is something that's really cool. I'm not going to walk through the entire portal. I know there was a talk on this yesterday, and there, Uma, the CEO of Chaos Native, the company behind Litmus, is going to be giving a talk later today, which I highly recommend. So I'm sure he'll walk you through all of these things. So for now, we're going to focus on Chaos testing this particular application. So I'm here, right? So I'm going to schedule my workflow. And I want to walk you through how you build your own. And then I'm going to show you how you reuse that effort as you continue to test. In this case, I didn't have one agent, the one on my cluster, so I pick it. And I'm going to create an experiment from the hub that I show you. I'm going to use the open source one, Chaos Hub, so that you can all try it out. And we're going to call this, what are we going to test? This is one of the key moments when you're Chaos testing, is deciding, okay, what is the scope of my experiment? So for today's experiment, what I want to try out is a scenario that is very common, and is one of the scenarios that I always recommend people they start with, which is test what happens when your databases are gone. In this case, we're going to do a Chaos experiment to see what happens when Redis is not responding. In this case, we're going to simulate that by deleting the Redis database, and we're going to see what happens to our application. So we're going to go back here, and we'll call this delete Redis. And just let's workflow to test what happens if I delete my Redis instance. Pro tip here, one tip is take a minute and write meaningful descriptions, especially when you're going to share these workflows. Because for you, it might be obvious, and you can just call it, hey, workflow 1, 2, or 3. But going back to kind of the same concept, think of this as how this is going to augment your team's productivity, not just your own. So if you have a clear description, anybody else that comes and sees the catalog and sees your experiment is going to be able to understand what were you trying to do. So what I like to do, the name, I like to do action and who's going to receive that action. But in the description, put what are you expecting to happen? What's going to be deleted? What are you testing? In this case, Chaos workflow to test what happens if I delete my Redis instance, telling us that we're attacking Redis. That is more exploratory. If you knew what was going to happen, you could put more specific things. But for now, we're going to leave it like that. And now we're going to build a workflow. This is the flow that you normally use the first time you build an experiment. After you build it the first time, then you have a YAML file that you can just directly import into the portal. It gets easier, but I'm kind of taking the long road just to show you different pieces. So in this case, and I mentioned before, all of this is coming from the open source Chaos Hub. But today, we're going to go with pod delete. We're going to delete the pod where Redis is at. So done. And now when you add it, it will add it with the default values. What I'm going to do now is I'm going to click on it to customize it and target our specific application. And I'm going to leave the name and experiment as is. It needs to be unique. This is what matters, right? So going back to Okteto, one of the things that Okteto gives you is this kind of namespace management. The same thing that you do manually, but in a nice graphic way. So I have my namespace Chaos Week, which is where my application is running. So I'm going to go here. And the first thing I'm going to do is I'm going to change the namespace to Chaos Week. You see that one of the cool things of the portal is it's reading all my settings from my cluster. So it just gives me this nice drop-down to pick the namespace where I'm going to be running this. Then in this case, it's a deployment. My Redis instance, it's a deployment. And then here, in this case, is going to ask you for, hey, which label to target. In this case, I'm going to pick this one, the Redis label. Litmus works like most things in Kubernetes through labels. That is how he can find things. In this case, for the pod delete experiment, he's going to use this label to find pods that match this label, and then he will randomly delete one of them. And then this is a policy for like after the experiment is run. Do you want the results to be deleted, or do you want them to be kept? For now, I just delete them, but you can change that if you want. And then finally, I'm not going to do that for this experiment because it's more complex, but you can always define the steady state of the application. When you define this, what this means is you want Litmus to do an experiment to say, hey, is my application running? Which typically means, hey, call an endpoint and make sure it's healthy. Then it's going to run the experiment, and then you're going to check the proof again. If this call fails, the experiment will fail. If it succeeds, then it's successful. This is very important once you're thinking of automating your chaos technique, because that's when you know, hey, did my experiment actually succeeded or not? For now, I'm going to leave it empty, okay? So I'm going to click next. This is, experiments can have, workflows can have more than one experiment. When you have more than one experiment, you can give them different weights and ratings, because as you get into more complex chaos testing, sometimes it's hard to tell if something passed or not. So if you add points, you can decide, you know what, as long as I get 70 points, that's fine. Maybe you have like 10, 15 steps doing different things. It depends on your experiment. Today, this is simple, one action, passes or not. So I'm just going to leave it at 10 points just for that. And then you could schedule accordingly, if you want to have this automation running all the time. But in this case, we're going to run it now. So here you can see the YAML. What I recommend you do once you have an experiment that you like is take this YAML, copy it, and put it in your repo. On the repo I'm going to share later today, it's right here. I added this. And I do that because then anybody can take this YAML, import it into the portal, and run their own experiments. And going back to what I was telling you earlier on, if you want your developers to embrace chaos testing as part of the dev cycle, we have to make it easy for them. So today, you have the YAML and you import it. In the future, I've been talking to the Litmus team about maybe doing some CLI. You can start your workflows, an API, and you can build something on top of it. It's the beginning, so get involved. That's one of the beautiful things about open source. So just give it a try. All right, finish. So at this point, you'll see this is running. So what's going to happen now is that Litmus is going to start the experiment. It's going to run a pod on the Litmus namespace. It's going to install the experiments, which in this case means creating the scripts and getting the necessary Docker images, container images, I should say. And then it's going to run the experiment on my namespace. If we go here, you'll see that in a few seconds, as the experiment runs, this pod, and take a look at the name, HSJJ, it's going to be restarted. So now what I'm going to do is, as this runs now here, I'm going to simulate calling the same API we called before, right? Right now it's working. Perfect. It's working fine. Now let's see. We can click here. You can see the logs are happening. The experiment is now running. As you see the logs come out, that means the experiment is running. In this case, I configured the experiment to last for 30 seconds and to try 3 times. So it's random. A lot of the things that happens on chaos testing are random. But if you see now, we don't have a race instance now. So if I go back here and I click on send, this is happening. What happened? It came back, but it came back empty. If you notice, there was 2 things that we discovered with this experiment. One is we don't have timeouts. That request took multiple seconds where it was just waiting and waiting and waiting and waiting. And number 2, when it did came up, it came up empty, right? And now, if we do another one, it's not even responding. It's taking a lot of time. You saw that 5 seconds. This is the beauty of chaos testing. You run your experiment, you're trying something, and you find all these different things that, you know, when you were writing code, you didn't thought about it. Because when we write code, we never think, like, what happens if my database is slow? What happens if one of my in-between services are failing? But when you kind of change your hat and put your chaos engineering hat on, this is what happens. So now that we know that our application has trouble dealing with Redis going out, let's try and do some development and see what happens. Now, for this, I'm going to use the Okteto CLI tool. The Okteto CLI tool, as I told you earlier, it's open source. If you go to github.com/Okteto, you can check it out. What it does is it lets you deploy a dev environment on Kubernetes so that you don't have to install any of your dependencies locally. And number 2, so that you can develop directly in your cluster rather than having to write code locally, build an image, redeploy, and do all those things. So for this, I'm going to open a terminal. You can use everything in a terminal. I did pre-install the Okteto CLI tool. The Okteto, all the commands you run will depend on your local kube config. So in this case, my local kube config is already configured to use the Chaos Week namespace. You can see it here. I have one of those like super handy shell plugins to tell me my cluster and my namespace. Highly recommend that if you're working on Kubernetes. And you see we have books, gateway, and Redis. So in this case, books is the one that's dealing with the Redis connection. So we're going to go to the books directory and run Okteto up. While this runs, what Okteto up does, that is the main command for Okteto, is it's going to look for this file on your repository, which is going to tell Okteto what deployment you're going to be targeting, and optionally, if you want to change the image. What Okteto is going to do behind the scenes is find this deployment, change the pod on the fly to do this, what we're calling like dev time overrides, new image, different command. You could inject even other environment variables. But there's 2 really cool things about this, very useful. One is you can tell it which command you want to run. And if you do something like running a bash, you directly get a terminal into your container. And the other thing is that it's going to automatically synchronize any changes you do on your local machine into your container. In this case, I'm going to show you, I'm going to do env. And you'll see that I'm getting the entire environment of the containers because this terminal is running on Kubernetes. At this point, there's nothing running, like my terminal is clear. So if I were to go and call this API again, you'll see that it's going to fail. And by the way, this shows you another issue we have with our code, that if we were to do a chaos experiment of killing the books service, we'll see that, hey, you are actually sending back stacks all the way to the client. So after the call, after the talk, give it a go and see if you can fix this issue. It's a cool one to experiment with, but today we're going to focus on the back end. So we have a terminal into the container. We have a dev image that has all of our dependencies installed. And by the way, Okteto works with any container image. Here, I pre-created one with Node that has a debugger and the Node 12 runtime. But this could be anything. This could be any image you want. So just as if I was developing locally, I'm going to do your install. This is going to install my dependencies, which in this case are GraphQL, the Redis client, something like that. This is something you only do once, because after this, all your dependencies will be cached, everything will be ready for you to go and for anybody else in your team as well. Because as you see, all of these things are coming from the repository. And then I'm just going to do yarn start. This will start the GraphQL server. So if I go back to Insomnia and click send again, now we're seeing that the information is flowing. So now let's try this again. At this point, you have your application running, but now it's hooked up to your dev container and to your code. So you could go back again and run the same experiment once again and see what happens. But now on your dev environment, right? You don't have to wait for CI. You don't want to wait for a release to be caught. You can just do it here. So in this case, I'm going to import it from my YAML. It's the same YAML I showed you before. Next, in this case, we'll leave that empty because we're experimenting with it. And same as before, we're going to run it. Now, as I said, and I want to iterate on this, what's really cool about this setup is that now I'm running my chaos experiments against my dev environment. And because I'm using Okteto, my dev environment looks a lot like production. I have microservices running in Kubernetes. I have a data store there, all these things running there. So we're going to see here, same as before. Chaos experiments will be stalled. It will be spin up. And eventually, we'll get to the point where Redis is deleted. And we're going to be able to test the results. So as always, the first thing you want to do when you're testing is make sure that your data, the application is working. You want to make sure that you have a baseline. So before, let's add a few more of this. Let's see if we can reproduce that issue where our data was gone. I just added 2. They're there. And you'll see now it's already hanging. So what happens is that now the pod delete experiment is running. So at this point, we have a repro of our bug. It's like, okay, clearly something is wrong here. You should not see a connection hang for this many seconds. So I'm going to cancel this. Go back to the code. And let's see what's going on. In this case, everything indexed, as I said, very simple code. So you'll see this. In this case, simple issue. We don't have a retry strategy, which means that when my connection fails, it never connects. And in this case, some dev, me at a different time, said, you know what, let's not bother with a retry. Things never fail. Why do we even bother about adding this overhead? And this is something that happens a lot. This is kind of a fake failure just to kind of make the point. But things like this happen a lot because when we're developing locally, you never think about things that could fail because localhost never fails. You have 2 services, they always talk to each other, they're always fast. Once you move to production, where you're talking about different networks, different nodes, different containers, things might be different. So in this case, okay, we know what's going on. We're going to fix that by saying, okay, instead of false, return the wait time before retries. And just for fun, we'll do it times, which is how many times you have retried, times 1,000, so that it will be 1 second, then 2 seconds, then 3 seconds, and up to the maximum, which I believe is 10. So I'm going to save this. And this is where Okteto becomes really handy because I can just Control-C my process, join start again. I don't have to rebuild the container. I don't have to deploy my application again. And now my application is ready to go again. So at this point, I could just rerun this experiment again, but I'm going to take a shortcut because now we know that where we're testing is if Redis dies. So I'm going to go here to Okteto UI and click destroy. This is the same as if you're on your own kube cluster, kubectl, delete pod, and the name of the pod. So I'm going to destroy this. See, now it's gone. Now let's call it again. And you see it's still failing because it hasn't returned. So now let's try what happens when Redis comes back. So what I'm going to do is I'm going to relaunch my Redis instance by doing Okteto stack deploy. Okteto stack deploy is going to take the compose file, or in this case, I named it Okteto stack, but it can be a compose as well. And it's going to deploy my application again. In this case, it'll notice that Redis is failing, so it's missing, so it's going to add it again. And you see here, Redis is back, and then it's going to reconnect to my my dev container. Is going to do the same thing it did before, but now it's going to have this new code. So now we're going to see what happens when Redis restarts. Start. Okay, it works. Again, you see my data is also lost again. So we keep seeing that issue. We'll get to it in a second. So now I'm going to go back here. And now instead of delete, we're going to kill the pod. So restart will just force a new pod to be spin up, something I do a lot in tests. So now we're going to back here again. And you see now it didn't hold. It pretty quickly recovered. That is because now this code has been executed. If you look at the logs, you'll see that, hey, what happened here? My connection was resetted. But now because I do have a retry strategy that is not non-retry, now when Redis goes down, we know that it will answer back. So at this point, I'm done developing. You can, try a few more times if you're comfortable. But let's say that we know now that our application is resilient to Redis issues. So now I can do something like exit Okteto stack deploy -- build. What this is going to do, sorry, wrong folder. What this is going to do is redeploy my application, but now it's going to also build my images so that I have even a more production-like setup. I went from dev container, live coding, seeing my changes in real time. Now I build my application so I can go back to the state I was before. It's going to take a couple of seconds to reboot, to restart. But I go back to like the initial setup where I know that now things are going to work. So if I run my experiment again, now we're going to see different results. So one thing I forgot to write is when you're done developing, if you do Okteto down, that will restore how things were before. You see everything is running now. Now we should be able to call this. So it'll take a few seconds for it to come up. Now, what happened? We discovered two things here. One is that our application is not resilient to Redis failures. But the other one is that our application loses its data when Redis goes away. Why is that? Well, what happened, actually, this happened to me last night. It took me a while to figure it out, and it was thanks to chaos testing. What happened was that when I deployed Redis, I didn't put a volume to it. So in Kubernetes, if you don't declare persistent volumes, the volume only lives for as long as your application lives, which is not what you want, right? You want your data to be long-lived, unlike your pods. So this is something I discovered through chaos testing. So what I can do now is I'm going to redeploy my application, but now I'm going to use the other. I'm going to use my other file. And if you look at this, this is the same format that Docker Compose uses. Okteto Stacks implements and extends the Docker Compose spec. So if you have a Docker Compose that you want to run in Kubernetes, just type Okteto stack deploy, pass the name of your file, and it will just work. So in this case, I redeployed my Redis instance. Now you'll see that there's a volume there. Now you'll see that things are getting more interesting. Now I have a volume. Now I have everything up and running. My gateway is ready. So now when I call this, it's empty. Okay, let's put some data. Let's do my 5 books. And then let's get them. You see they're there. And now, actually I haven't tried this before, so let's see what happens. We're going to go back to limit portal, go home. We are going to schedule our workflow. And let's just build it. Same thing we did before. In this case, is the status set because now we have a data volume. If you go back here, we need to find our label. In this case, here you go. Finish. And we're going to schedule it. And then, same as before, the workflow is going to be installed. Our experiment is going to be instantiated. It's going to start. It's going to find our Redis instance. It's going to delete it. And then we'll see what happens. This is a simple example. Like I said, you probably are asking yourselves, like, why do I need all this UI, all this YAML for like just testing how pod gets deleted? I'm using a simple example to illustrate the different points and how you can use these two tools. Reality is that once you get deeper into your chaos testing journey, you're going to start to write some more complex workflows. You're going to write workflows where you might delete several things at the same time and then wait. You might do things like inject memory. There's an experiment that actually increases the amount of memory a container is consuming, that blocks the network, that starts to put like fake traffic to test all the different situations that we normally see in production. So at that point, these things get more interesting. This is when you're running all these kind of like more complex experiments, when you're going to start seeing all these odd behaviors of your application. But as I shown you today, even just testing for, hey, what happens when a pod gets deleted is enough to start uncovering a lot of issues. After the talk, take that example app, take these experiments, and try to see what happens when you delete other pieces. And you'll be surprised of all the different things that you can find that if you write code to handle, the experience will be very degraded for your customers. So we're going here. In a second, you'll see that this will change. We'll see that the pod restarts once the experiment finishes. And then finally, we'll call the app, and we'll see what happens, right? We expect the app to deal with this. You're gonna click on this, and if sometimes your experiment is taking too long, you can analyze it. You can see the logs here. You'll see now, okay, it started. Switching 1 minute. It's a 60-second experiment, so it'll be not a second. But if for some reason it fails, in this case, maybe I got the tag wrong, maybe because it's a stateful set, I didn't pass any volume. You can always go to the portal, edit your experiment, and run again. So in this case, just to make things faster, I'm going to do it manually. We're running out of time for the talk, so I'm going to restart my Redis instance. It's failed. This is the same thing as experiment. It is a pod. I'm doing it manually to have more control. We're going to go here, and you'll see that now we didn't lose data. And why? Because now my Redis is backed by a persistent volume, which means that if the pod goes away and comes back, the volume will not go away. And this is an example of how you can use Litmus and Okteto to develop together, to have access to your chaos testing as part of your dev environment, and not just on CI/CD or even after that. If this is something that you liked, all the things I show you here are open source. So go to github.com/litmuschaos/litmus or Okteto/Okteto. Please, if you like, start the repo, open any issues and ideas that you might have on things that you want to see. The community, both Litmus and Okteto, we're always looking for people to just ideas, even if it's something you're not willing to commit to do. Just put your ideas out there. Join the Slack channel, the Discords. One of the really cool things about building open source is having access to users, developers, practitioners, and together we build software. And if you want to try this out on your own, go to my GitHub repo, chaos-week-2021. I'll share this later, and try it out for yourself. So, before I finish my talk, before we go to the Q&A part of the talk, 5 things that you should take home after this. Number 1, chaos testing should be done at all stages of the software development lifecycle. Don't wait until acceptance tests. Before writing code, when you're writing code, after you merge code, if you only do it in one phase, you're losing a lot of its power. Number two, if you don't chaos test, your customers will do it. Because things like a Redis instance being offline is completely outside of your control. It can be that Amazon is having an outage. It could be that your network is having congestion. It could be that there's a bug in Redis that causes it to reboot every 5 days. Any of these things are completely outside of our control. What's on our control is what our application does when that happens. And if we don't do the work, our customers will suffer. Number three, as you think of this, find tools that make it simple for everyone in your team to do chaos testing. Today, I show you a workflow where you can use Okteto and Litmus to have this as part of their cycle. There are many other tools. What's important for you is to think in this scope. Make it easy, one click, one command. If you can get it to where people write make chaos, and that makes everything go, that's much better than having a README with 25 steps, because those people are not going to do them. They're going to wait for CI to automate it. And then they're going to get benefits. They're going to go slower. So make it simple for everyone. So make chaos trumps READMEs. Make it easy, scripted, make it available to everyone. And finally, and I want to really repeat this, automate, automate, automate. If things are not scripted, if your experiments are not pre-created, it's not going to be part of your day-to-day. It might be something you do once a month. Maybe you do it before the release, which is okay, but it's much better if you do it continuously. The same way that we now have CI/CD, where you don't have to remember to run your tests. If you just run them as part of a PR, think of chaos testing in the same scope. Make it easy, automate it to run without having to think twice about it. And that's it. Thank you so much. I hope that you find this talk useful. As I said in the beginning of the talk, Ramiro, you can find me on Twitter as Berrelleza. Always happy to talk to people about open source, cloud native, chaos testing, startups, all of those things. Please, if you like this talk, if you find it useful, do tweet about it. Do go to our repos, start them. That is something that is always helpful. It's an easy way to show support for these open source projects that people want to work on. And I hope that you enjoy the rest of Chaos Week. And this is all for me. If you have any questions, well, now's the time. Akram's been looking at the chat, and there might be some things there.
Well, thank you, Ramiro, for this amazing presentation. And yes, it was very great. I have some few questions. I don't know if there is a question in the chat or not. I think that no. It was very clear, I think. So for me, I have some question. First of all, I would like to see what is the approach that you have taken to convince the team with the continuous testing.
That is a really good question. The approach that has worked for me in the past is a kind of two-pronged strategy. The first is you need to convince your team of the benefits. That's where I think efforts like Chaos Week, all the videos that the Litmus community are putting out, all these talks. Because if they don't believe that there's a benefit in their effort, they're going to do it, right? The same way that, 10 years ago, I remember that I was in teams where unit testing was a controversial subject. People were like, no, we don't need to test. We just do it once. We need to test in same thing is happening now where first you have to sell them on the concept. Why do we need to chaos test? Because applications are complex. Because not everything can be tested end-to-end anymore. It's not just like this demo is hey, request and it failed. Sure. But in real life, something like what happens to your website when you have 10,000 customers trying to log in at the same time and your database is being throttled. Those things are real and they're not easy to test in a local environment. So number one is convince them of the value. Really, there needs to be an education aspect of this. And that's where I love all these talks. If you go to all these Chaos Native put a conference earlier this year where you had people from all these big companies talking about why they put this efforts, why they build these frameworks. That for me was a really cool way. You see a cool conference, You share that with your team on your team Discord or Slack. Like, hey, look at this, and you're gonna plant the seeds. We should do something like this. And then number two is typically what works is you need a champion on the team, like someone who really believes in this, and who's gonna do the kind of like heavy work at the beginning, creating the experiment, like the base experiments, even like fixing kind of like the low hanging issues. Like the example I showed you today, not kidding, it's very common that code doesn't handle things like your SQL queries timing out. Because we never see that as a developer. You're writing code, and of course it always works. It's just you in a database, and if it doesn't work, you restart Postgres. But in production, it's not the case. So those two things, having a education and then this champion to set things up. And that's why like the idea with this talk came from there is like, I'm a big believer in automating things, because if you don't have to think about it, if you click one button and your chaos experiments just run, that is great. That is like you click, you see it, it becomes kind of a muscle. It's part of your release process. It's part of your PR process, to the point where at some point it's like if you don't have that, you feel like, hey, I'm missing something here. So it's all about, at the end, building trust. Like you want your team to trust that by following this process, you're going to have more quality, and that's something that slowly, you build the practice, you build the muscle, you start small, and then you get to a point where you have a chaos expert in your team, maybe a few, and that's where things get super interesting, because then you can get to like the more complex things. And at the end, we all build software to solve problems. So it's just another tool to ensure that we are solving the problems at the scale we want to solve. So those two things, went kind of like too long on this, but educate your team on the benefits of chaos testing. It's a new thing. It's getting a hot topic. I agree with Michael. It's becoming very hot. CNCF put out a report that is like one of the, if not the biggest trend. It was like definitely top 3 of like the hottest trends on cloud native. Educate, sell on the benefits, and then make it easy for them to try it out in that order. Because if you just throw scripts at someone and say, hey, now you have to do this, no one's going to do it.
Well, thank you, Ramiro, for the answer. So I would take that as an advice also for the teams that fear chaos engineering also. Yes, that's
nothing to fear. It's a lot of fun. It's actually, I think I find it very entertaining to do these sessions where you try different experiments just to see what happens, and that's something that, if you're like that slide that I put at the beginning, that's why I like the word experiment. Because I feel like emotionally, it's not like you're wrong or like you did a bad job. No, it's that you're experimenting to see what other things you find. The same way you experiment with, I don't know, with food to see which food you like, or with different IDEs to see if you're like a VS Code person or a Vim person, like someone on my team is. It's an experiment. So it's a fun way to discover things, and it's a fun way to find things that need to be fixed. And it's challenging, but it's also rewarding. So don't fear chaos testing. Definitely enjoy it, learn it. I agree. It's something that's gonna move. It's moving from, hey, this is nice to have, to this is a most. Now there are companies like Gremlin, like Chaos Native, really pushing the envelope, and I'm very excited to see that. It's one of those topics that I've always found fascinating, and now that it's getting more and more practitioners, it's even better.
Yes. So in the same way we are having now, there is another talk that will start. That's starting. Talk of Yuri Nino, which is about the predict chaos with machine learning. So
wow.
Yes, it's a great talk. So yes, I invite you all to visit it and to be present. So thank you, Ramiro. It was great to have you, and maybe we can see you next year. Or for sure, we will see you next year for the second edition of the Chaos Week.
For sure. Yes. Thanks for having me, Akram, and I really appreciate that for you and your team are putting on Chaos Week. This is great. It's a great way to get people involved, teaching something new, help people meet new people in the space, and yeah, looking forward to Chaos Week 2022.
Yes, thank you very much.
Bye.